wondered how lighters work? It's magic!
Chemistry magic.
Our group will be talking about the magic behind lighters.
There are basically two different types of lighters, Zippo lighters and a regular disposable lighter. Zippo lighters are very decorative and are refuelable. Regular disposable lighters are plain and disposable. There are also household and utility lighters that are used for hard-to-reach candles and also safer than a Zippo and a regular disposable lighter. They have a handle and a long reach, which helps prevent any burning of fingers and hands.
You're probably asking yourself, how does my lighter work? Let's go inside a lighter and see. Butane lighters, such as this disposable Bic lighter, work by turning a wheel which creates a spark from the flint inside. The spark from the flint ignites a wick which is soaked in butane, creating a flame. Oxyacetylene torches use a spark lighter, or sometimes called a strike lighter, to ignite the acetylene gas. A spark lighter, such as this one, works by squeezing a handle which creates a spark from the flint. Once the flame is lit, the oxygen valve is opened to fuel the flame. Oxyacetylene torches are commonly used for blazing and welding metal.
A little bit about lighters, and that there is more than one fuel for them. Let's take a look at the most common one, butane. Okay, well, it's not straight up butane, it's actually a butane isomer. But anyways, the combustion reaction for the butane isomer is 2C4H10 plus 13O2 yields 8CO2 plus 10H2O. The bizarre thing about butane is that its boiling point is negative 11.7 degrees Celsius. So at room temperature, it should be a gas. But in a lighter, it's a liquid. So how does that one work? Well, the butane starts as a gas, but during the process, it's compressed so much that it's forced into the liquid state.
Alright, now let's talk about acetylene torches and lighters. Acetylene is also commonly known as ethene, and its chemical formula is H2C2. Acetylene is a colorless, odorless, highly flammable gas that burns as a hot, bright flame when introduced with oxygen gas. In the past, acetylene was used as a torch to illuminate rooms, but because of its dangerous natures, such as extreme high temperatures and explosive characteristics, butane is more of a common choice. Acetylene is commonly used as an oxyacetylene torch that is used to wield and cut metals. Acetylene can be made by combining calcium carbide and H2O. The combustion formula is 2H2C2 gas plus 5O2 gas yields to 4CO2 gas plus H2O gas.
I'm going to tell you a little bit about the fuels lighters use and how hot the ignition source has to be. The flash point of a volatile liquid is the lowest temperature at which it can vaporize to form an ignitable mixture in air. Measuring a liquid's flash point requires an ignition source. The flash point is often used as a descriptive characteristic of liquid fuel and is also used to help characterize the fire hazards of liquids. The flash point refers to both flammable liquids and combustible liquids. There are various standards for defining each term. Most people agree that liquids with a flash point less than 141 degrees Fahrenheit are flammable, and liquids with a flash point above these temperatures are combustible. The fuels used in lighters are combustible. Butane ignites at 761 degrees Fahrenheit, and acetylene ignites at 581 degrees Fahrenheit.
What makes the color composition of the flame produced in butane gas lighters? Flame colors are produced from movement of electrons in the carbon ions present in butane. The electron jump to higher energy levels is called excitation. When a flame is blue, it means the carbon ions have become very excited. Blue flame is caused by the complete oxidizing of hydrogen in butane gas. This is also called complete combustion, which is brought on by a higher temperature. When a flame is yellow, it means the carbon ions have become excited, but not as excited as in blue flame. Yellow flame is caused by the incomplete oxidizing of hydrogen in butane gas, which is brought on by a lower temperature.
You've probably noticed, or will notice, that in our video we only use lighters with one colored flame. However, you can get a lighter with any color flame that you want. You could get a blue flame, green flame, orange flame, red flame, any color. In order to change the color composition of a lighter, an additional chemical is needed. For a blue flame, you would need to add cupric chloride to the lighter. For a red flame, you would need to add lithium chloride or strontium chloride. For a green flame, you would need to add copper sulfate or borax. For an orange flame, calcium chloride would need to be added to the lighter. For a purple flame, potassium chloride would need to be added. And for a yellow flame, sodium chloride or sodium carbonate would need to be added.
So you've heard a lot about lighters by now. But what about the colors of the flame? Why do they matter? Well, those colors are part of the light spectrum. As you can see, the light spectrum is quite broad, but this tiny sliver right down in here is a visible light spectrum. In other words, it's viewable to the human eye, and some everyday lights are made up of these colors. Watch. The reason the order is so important is because if you look up here, you can see the squiggly line. This squiggly line shows the corresponding wavelengths to the color. So to briefly diagram a wavelength, these are called the crests, and these down here are the troughs, or valleys. The shorter the distances between each crest, or trough, dictates how much energy there is for that corresponding color. So as you can see here, a typical flame really isn't that high of energy. It is mostly orange or red, yellow, and green. But there are some things that can create a really intense flame, such as Zippos or Bunsen burners, which have a blue cone in the center. So that concludes a short overview of the light spectrum and how it relates to the flames lighters produce.
Chemistry magic.